Okay, guys, let's get started without any further ado. So, in the last class, we took a demo on what the course is about. On the Certified Ethical Hacking course, we had discussed what hacking is, what ethical hacking is. We discussed what the different categories of hackers are, what the hacking cycle is, what is the entire procedure that is followed by hackers or cybersecurity professionals in an organization, either to attack the organization or to defend the organization from the same attacks. So, we discussed what the 5 steps of the hacking cycle, which also elaborated to you what different topics we'll be covering throughout the entire course. So, Aman, if you don't have that recording, you'll be getting it from the institute. Okay. So again, that was the last session we took, I think, on Friday, if I'm not wrong. So you'll be getting that recording. And Varalakshmi, I think you were there for that session for the last class, right? We took that demo the other day. Right. So in today's class, guys, we'll be working with the first class in the hacking course or the certified ethical hacking course, which is networking fundamentals. One of the most important prerequisites for cybersecurity, understanding what networking is and understanding what IP addresses are. Again, what some important networking protocols are. Because when you work in cybersecurity, you'll be coming across a lot of log files and a lot of network traffic analysis. So in such cases, you need to understand what these protocols are, what is TCP, what is UDP, what are IP addresses, what are public IPs, what are private IPs. Like how do you differentiate them? What are different again TCP or UDP based protocols, okay, or services? It's important to know all this, and that's what we'll be covering in this topic. Okay. So when you talk about networking fundamentals, there are 3 important definitions to begin with. What is networking? What are networks? And what are hosts? So when you talk about networking, this is sorry. Yeah, when you talk about networking, this is the practice of connecting information devices with each other to share resources or data. Okay. Now, in an organization, you have multiple sorts of endpoints. You have your routers, you have your switches, you have your firewalls, you have your client operating system devices, the Windows 11 or Linux workstations. Okay. You have your servers again, FTP servers, DNS servers, DHCP servers, SMTP servers. Okay. Then you have again IP cameras, we have printers. So the process of connecting all of these information devices with each other in one single connected network, in one single group, a collective group to share information or to share resources is called as networking. Okay, and that collective group of devices is called as a network. So a network is a collection of those interconnected devices which can communicate and transmit data to each other. Okay. And in that network, each of those endpoints, each of those individual devices is called as a host. So a host refers to any device, any individual device connected in that network that can transmit or receive data. Okay. Again, as mentioned, computers, routers, printers, mobile phones, cameras, servers, whatever. Okay. Now, just like how we humans have our names to identify each other and address each other by those names respectively, these devices also have names, and those names are called as IP addresses, Internet Protocol addresses. Okay, so Internet Protocol addresses were built by the US military in the late 1950s or so. There were multiple versions of it again. There was IP version 1, IP version 2, IP version 3, etc. etc. They didn't work out successfully. What properly panned out was IPv4, Internet Protocol version 4. Okay, by the US military. This was generated outside. And again, even though it was quite old, like I think it was in 1950s or so, which was developed, we are still using IPv4 addresses even in today's world. Okay, so today we'll talk about the properties of IPv4 addresses and the range of IPv4 addresses. Okay, so firstly, to define an IP address, as mentioned, each device on the network has a unique identifier. Okay, each host on the network has a unique identifier, and that unique identifier is known as an IP address. And these IP addresses allow for communication to occur between the hosts. Okay. So when one device needs to communicate with the other device, they are connected with each other on the basis of these IPs itself. Okay. Now let's talk about a few important properties of IPv4 addresses. Firstly, your IPv4 address is a 32-bit address. Now, what I mean by 32-bit address is that it contains 32 zeros or ones consecutive. So a bit is the smallest data value an information system can store. Okay. It can either be the value of 0 or the value of 1. Okay. So the smallest data value a computer holds or stores in its memory is called the bit. Okay. Now, your bit value, which is either 0 or 1, is again in IPv4 addresses 32 times repeated. Okay, so you have 32 zeros or ones consecutively. Okay, and this entire 32-bit address again is divided in 4 equal parts of 8 bits each. Each of that 8-bit portion is called as an octet. Okay, and each octet is separated by a dot symbol. So this is what your typical IPv4 address would look like in the language of zeros and ones. So you have 8 bits here, 11000000, for example, let's say. So these are 8 bits here, then a dot, then another 8 bits, then a dot, then another 8 bits, then a dot, and then another 8 bits here. Okay. So in total, that's your 32-bit IPv4 address. Now, what you see here is also commonly known as the binary language, guys. Language of zeros and ones, only 2 characters. So that is something which is very easily understood by the computers. But we humans don't understand binary as soon as we look at it. There's a method to calculate a binary number to a human readable decimal number. So this number 11000000 is actually equal to 192 in human readable language. This number 10101000 is actually equal to 168. This number, all zeros, is simply equal to 0. And this number 00001010 is actually equal to 10. Okay, but no way, as mentioned, I'll be showing you a technique, the technique required to convert any binary number to a human readable decimal number now. Quite important. Okay. Any questions or doubts in this slide up to here? Aman, well, Lakshmi.
Are you gonna teach the method how to convert this?
Yeah, I'm going to show you now, Aman. How do you convert a binary number to a human readable decimal number? Was that your question?
Yes.
Right. So we're going to learn that now. Okay. So now to convert any binary number to human readable decimal number, there are 2 simple steps required. Okay. So let's say we take this number here, 10101010, an octet of binary bits. Okay. Now to convert this, the first rule is you write down the values of 2 power from right to left in an increasing order. So the rightmost bit has 2 power 0 under it. Then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So under each binary bit from right to left, you're writing the values of 2 power numbers. Okay. Again, starting from 2 power 0, going all the way up to 2 power 7. Now, if you have a question why specifically 2 power, this is a binary address. You only have 2 possibilities, 1 or 0. Hence 2 power everything. Okay. Once those values are written down, then you multiply the lower 2 power value with the top bit and you keep on adding it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So no matter what the binary bit be on the top, whether it be 0 or 1, you multiply the lower 2 power value with the top bit and you keep on adding it till the end. Okay. Now to calculate these, let me write down the values of these numbers first. Anything to the power 0 is always equal to 1. That's a mathematical rule. So 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2. That's 4. 2 power 3 is 2 into 2 into 2. 3 times. That's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Okay. So now that we have these values here, we can substitute them over here. Okay. So 2 power 0 into 0. What is 2 power 0? 2 power 0 is 1. So 1 into 0, that's simply 0. Plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2 itself. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. Now that you have all these values, if you add them up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. Something very similar to high frequency, low frequency, high frequency, low frequency, high, low, high. When that exact sequence of frequencies flows through a computer's memory, it stores it as the value 17017. Okay. Is that clear, everyone? Any questions? Aman, Varalakshmi? Right. Aman, have you understood as well?
So this is equal to 170. This was the second one, right? Wasn't it 168?
That's a different number. I mean, if you observe, this is 10101010, and
Oh,
that
that's what.
number
Okay.
was 10101000.
Okay, got it. Okay, I got confused. I'm clear now.
Right. So now, if you have understood this technique, there are two more numbers here as examples. If you have a pen and a paper beside you, I want you to calculate the decimal values for these numbers and give me the answers for them. The numbers are 01010101 and all ones. I've written down the values from 2 power 0 to 2 power 7 over here. I want you to calculate these binary numbers and convert them to decimal numbers and give me the answer for both examples, example 1 and 2. Take your time, no rush. Calculate and give me the answers, guys.
So 85 for first one.
Coming in a minute.
85.
85. Okay, we'll check that. Any answers, well, Lakshmi, on your? Sorry, I couldn't hear you, Lakshmi. The first one. Any answers for the first one? Okay, guys. So let's verify the answers now. So I've got the correct answers itself. So again, as mentioned, you've got 85 for the first one. Okay, so again, 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0, so on and so forth till the end. So that would be 1 plus 4 plus 16 plus 64. And that would give you 85. And when you have all ones, guys, you get the value 255. Okay, because you just have to add all the numbers here. Okay, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And if you add all of them up, you get the number 255. Now, there's a reason for me to explain all this, guys. So from this conversion itself now, you can actually calculate the range of IP addresses. Okay. So if I had to get the first IP, what do? I just give the most least value there. Okay, the minimum value there. To get the least value, I can put zeros everywhere. So the first IP can be obtained by putting zeros in all octets. Zeros in the first octet, second, third, and fourth. And then when you convert that from binary to decimal, you get the first IP as simply 0 dot 0 dot 0 dot 0. This is the decimal value. And if I had to get the last IP, what do? To get the maximum value, I just put all ones. And when I put all ones, the maximum it can go up to is 255. dot 255 dot 255 dot 255. So no matter what IP address you take in the entire IPv4 range, they would always vary between 0 and 255. They cannot exceed beyond 255 because from your calculation itself, you would have noticed with maximum, again, when you put all ones, the maximum value you get is 255, not beyond that. Okay. And if I had to calculate how many IPs are there in total, each bit here has two possibilities. So 2 into 2 into 2 into 2. So these many number of possibilities, right? So 2 raised to the power of 32 bits. That would give you a total of, oh, sorry, that would give you a total of 4.3 billion IP addresses. So back then when these were invented in the 1950s or so, 4.3 billion IPs did seem like a very large number. Okay. But fast forward to 2025, the population itself is 9 billion people or close to 9 billion people. Okay. And each person again would have multiple devices, right? So again, if you had to individually assign each of these IPs to each unique system, they would have never sufficed. That's why these 4.3 billion IPs are again divided in various categories. There's public IPs, there's private IPs, there's classes. Okay. So we'll talk about those categories in a while. Let's talk about the sequence first. So now we know this is the first IP here. We know this is the last IP here. What about the IPs in between? How do the IPs progress? So we'll talk about that sequence now. Okay. So to understand the sequence of IP addresses, there are two simple rules again. Rule number one, you always start incrementing from the rightmost octet. So if this is the first IP, 0000, the next IP would be 0001. So the rightmost octet increments by 1. Okay. Then you have 0002, then 0003, then 0004. This goes all the way up to 000255. Okay. Now, after this value, you cannot have a number like 256. That's not possible in IP addresses. Okay. So then here comes rule number two. Once the rightmost octet reaches the maximum value, then you move to the left octet. So this 255 resets back to 0. And the left octet now increases by 1. Okay, so you have 0010 now. Okay, then 0011. So the rightmost octet increases by 1. Rule number 1, if you remember. So 101112131415 goes up to 1255. Then 20212223. This goes up to 2255. 30313233, which goes up to 3255. So if you see, there's a pattern here. 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255. Like the pattern keeps on repeating. And somewhere down the line, you would have 2550 to 255255. Okay. Now both these octets are filled. So this 0 now changes to 1. And then you have the same pattern again, 00. Okay, so 100 to 1255255. Sorry, 100. The 00 goes up to 0255. Then 10 goes to 1255. So the same entire pattern which happened here from 000 to 0255255. Same pattern repeats again from 100 to 1255255. 200 to 225555. 300 to 325555. Similarly, 25500 to 255255. Okay. Now, whatever pattern repeated from 0000 to 0255255255, same pattern again repeats from 1000 to 1255255255. Same thing repeats again from 2000 to 255255. Again, 3000 to 3255255255. 4000 to 4255255255. Like that, the pattern keeps on repeating. And finally, somewhere you would have 255000 to 255255. Definitely, I did skip a lot of IPs in between, but if you count each and every individual IP in this way, you would have a total of 4.3 billion IP addresses. Okay, is that clear, guys? Any questions regarding the sequencing?
Why it only goes up to 255?
Because if you calculated it, Aman, if you remember, when you put all ones, you get 255. How can you exceed beyond that? You have only 8 bits. And in those 8 bits, when you put all ones, maximum you're getting is 255. How will it exceed after that? Is my question.
So isn't 2 to the power of 8, 256 then?
But you don't have 2 to the power of 8 anywhere, right? If you remember, everywhere you're calculating, you only have 2 to the power 7 as the maximum, starting from 2 power 0, going up to 2 power 7.
Because it starts from 0, that's why it only goes up to 2 to the power of 7. Okay.
Yep, exactly.
Okay, that makes sense. Now I got it.
Right. Okay. So again, that's what the entire calculation was based on, and that's what you give the answers on, if you remember, right? So starting from 2 power 0, which is equal to 1, you go all the way up to 2 power 7. There is no
Yeah.
2 power 8 anywhere, right? So that's why it's only going up to a maximum of 255, not more than that anywhere. Moving on. So yeah. Anyways, moving on. So this is the entire sequence of IPs, guys. Now, this entire 4.3 billion IPs, this entire sequence of IPs is divided in various categories. There's something called as classes, class A, class B, class C, class D, and class E. And again, in each of these classes, there are subcategories. Class A has two subcategories, public and private IPs. Class B also has two subcategories, public and private IPs. Class C also has two subcategories, public and private IPs. Class D and Class E only have public IPs. There are no private IPs in them. These are exceptions. Okay. So we'll talk about what these classes are in the next session. Today we're going to discuss what public and private IPs are. Okay. What is public IP? What is private IP? Where do you use each of these IPs? Okay. How do you figure out what your system's public IP is, what your system's private IPs? We'll cover all that today. Okay. To understand public and private IPs, let's take the example of our home network. Now, in our home network, let's say we have a Wi-Fi router. And to this Wi-Fi router, we have multiple internal devices connected. Let's say we have our laptops, our smartphones, our smartwatches, our smart TVs, our IP cameras, whatnot, all of these devices in our local home network. Now, each of these devices, guys, is also commonly known as an intranet device or a local network device. Okay. Oh, sorry. Okay, so this router, this laptop, this phone, this mobile phone over here, the smartwatch, the smart TV, all of these are our own private devices in our home network. So in an organization as well, they might have hundreds of computers communicating with each other. Those hundreds of computers are their internal network. Okay, so whenever you have devices in your internal network, or also commonly known as the intranet, okay, there we use private IPs. Private IP addresses are local communication IP addresses. These IP addresses allow communication among every single device in a local network. So when your phone wants to communicate with the router, when your laptop wants to communicate with the smart TV here, they would always perform the communication on the private IPs. Each device here is getting a unique private IP. If you observe, the router is getting 192.168.0.1, laptop 02, smartwatch 03, smartphone 04, and your TVs 05. Each of these devices has a unique identity over here in the local network. Okay, so these IPs are called as private IPs. Private IPs are only for communication in the local network, in the intranet. But when one device wants to communicate with the other device in a local network, you always go for private IPs there. But when any of these devices wants to communicate with the internet, then you need a public IP. So your router gets a cable from outside your house. Okay. Could be an optical fiber cable, could be an RJ45 cable, whatever it be. There's a cable from outside your house coming and connecting to your router. If you observe, that cable is carrying the public IP, and that is provided by the ISP, Internet Service Provider. So when you take the new Wi-Fi connection, an ISP guy. So in India, we have ISPs like Airtel, Act Hibernate, Hathway, whatever. So when you take up a new internet connection, that guy sets up the router. He brings a cable from outside the house, from the closest hub, he brings a cable and he runs that cable all the way to your router, right? So that cable itself carries the public IP. And this public IP is given to you by the ISP, Internet Service Provider. Okay. And this public IP is shared commonly among all your devices to access the internet. So if my phone wants to communicate with google.com, first it sends the packet to the Wi-Fi router. So from its private IP, the packet goes to the router's private IP. Router has the capability of shifting packets across networks. So it can shift the packet from the private IP interface to the public IP interface. Okay. And with that public IP, now it reaches the internet. It jumps across multiple different servers on the internet and then finally reaches google.com. So this traffic on the internet, this traversal of the packet on the internet always happens with the public IP. Okay, so public IP is the IP address assigned by the ISP to an organization or to a local network to access the internet. Okay, all of these devices will commonly share one public IP to access the internet, guys. Okay, so to define each of these, as mentioned, when you talk about private IPs, these are the IP addresses used in private networks, such as home networks, offices, organizations. They're always used for local communication. Private IPs are not directly accessible from the internet. So you cannot access the internet directly with just a private IP. Okay. These IPs only allow devices within the same local network to communicate with each other. Okay. So in the same local intranet, they can communicate with each other using private IPs. And if you have to check what your system's private IP is for a Windows device, you can open up the command. Anyways, you can open up the command prompt cmd. Okay. And in the command prompt, you can do a quick search here, IP config. And when you do that search, you see I get a private IP over here. Okay, so this is what the private IP is. And if I had to search what my public IP is, on the other hand, public IP addresses are globally unique IP addresses, as mentioned. To define them, these are identified, okay, specifically on the internet. They're allocated by the internet service provider. They're routable over the internet. And to check what your public IP is, you go to your browser, and in your browser, you do a quick search here. What is my IP? Okay, and when you do that search, you can see this shows me my public IP here, provided by my ISP Beam Telecom, okay, in the region Andhra Pradesh. Excuse me. So, and again, it shows you your region, country, etc., etc. Okay, so this is how you check your public and private IPs, guys. Okay, any questions? Aman, Sudhir, when Valakshmi. Hello. Okay,
No, I'm good.
right. So yeah, again, as mentioned, guys, this is what public and private IPs are. But now if you notice, I in my command prompt, I get an IP like something like, oh, where is it? CMD. I get an IP like 192.168.0.5 here. Okay. And then in the browser, I get an IP like 49.204.238.131 here. So each of these public and private IPs, guys, has a specific range to it. Okay. So firstly, their classes, as mentioned, there are 5 classes. Each of these classes has its own range first. And again, in each of those classes, there's a separate private IP range. Okay. So the private IP that I'm getting here is in this range, 192.168.0.0 to 192.168.255.255. And the public IP I was getting was in this range between 0 and 127. If you observe, I was getting something like 49.204 something. Okay. That was in the public IP range and classic outside the private IP range. So we'll talk about these ranges, guys, in the next class. I'll explain how to memorize these ranges because it's quite important. Okay. And we'll also talk about what these classes are. So you might have a very simple question. Why 5 separate classes? Why not just one single class with some public and private IPs? It would have made the job easier, right? But no, there's a specific reason for it. We'll talk about the relevance of each of these classes in the next session. Okay. What is class C? What is class B? What is class A? Okay. What's the relevance of each of these classes? Okay. Then we'll talk about subnet mask. We'll talk about how to assign a private IP. How do you do it manually from the control panel? Okay, or how do you get it automatically from a DHCP server? What is the process that a DHCP server follows to assign an IP? Okay, we'll talk about the DNS server. Okay, what is a DNS server required for on the internet? What are special IPs? We'll cover all this in the next class. Okay, today we have learned what networking is. We have learned what networks and hosts are. We have learned what IP addresses are, and specifically the properties of IPv4 addresses. From those properties, we understood how to convert a binary number to a decimal number. We have got the range of IPs from that. We talked about the sequencing of IPs from that. And we talked about the categories, public and private IPs. Tomorrow, we'll be covering all these other concepts. Okay, is that clear? So, any questions or doubts before we exit the session today, guys?
When is the next class?
Same time tomorrow, Aman.
Okay.
7 a.m. IST in the morning tomorrow itself. Okay. So I think if you have registered with the correct email, you'll be getting the link as well. Amit. And I think the link should be same, but if in case it changes, you'll be getting it on your email with which you have registered to join the session today. Okay. So yeah,
Okay.
that's that. Nothing further. So we can exit the session here. Hi, Sudhir. Can you hear me? Yeah. Oh yeah. Well, Lakshmi, I'll cover IPv6 addresses as well. For now, in this module, we'll be covering only IPv4. In the upcoming sessions, once I talk about MAC addresses and all, there I'll be covering IPv6 addresses, which are hexadecimal addresses. So just not to confuse you right now, we are on binary addresses. We'll cover those also. Hexadecimal addresses also, IPv6. Okay. Right. So yeah, that's that, guys. Nothing further for the session today. We can disconnect here. We'll be connecting back tomorrow at the same time to learn about the upcoming concepts in networking. We'll be concluding the entire networking fundamentals tomorrow, guys. Okay. So please do join the session tomorrow without fail. Quite an important class. Okay. So yeah, that's that. Bye-bye. We can exit the session. Thank you. Thank you.